gentlemen, this is section 7.2 and 7.3 of Mrs. Quinn's geometry class. And today I'm going to start you off with some formulas. For the product of a power, if I know my bases are the same and I'm multiplying, I can add my exponents. And for a quotient of a power, if my bases are the same, sorry, I need to change this to an A. Only works if your bases are the same. If my bases are the same, I keep the base and subtract my exponents. Now for a power of a power, I get a to the x times y. When I'm raising a power to another power, I multiply. And then we have our last two where we take the power of a product and the power of a quotient. So if I am taking the power of a product, notice that since I don't have any exponents written for A and B, their exponent is actually a 1. And so we're going to multiply that power in. And I get A to the 1 times x, which is x, and B to the 1 times x, which is x. For a power of a quotient, again, if you don't have an exponent written, write it in as a 1, and multiply that power in. A to the power of 1 times x is x, and b to the power of 1 times x is x. So let's practice each one of these rules. If I have 2 to the 4th times 2 to the 3rd, does everyone agree that's going to give me 2 to the 4 plus 3, which is 7? And if I have 2 to the power of 4 divided by 2 to the power of 3, does everyone agree that's going to give me 2 to the power of 1? 4 minus 3 is 1, which is just 2. And does everyone agree if I get 2 to the power of 3 and I raise it to the power of 4, I'm going to get 2 to the power of 12. 4 times 3 gives me 12. And finally, if I have 2 times x to the 4th raised to the power of 3. First off, I need to recognize that 2 has a power of 1. So 2 to the power of 1 times 3 is 3. And x to the power of 4 times 3 is 12. Are you getting the hang of it? For this last one, what if I have 2 squared over x cubed, all raised to the power of 2? Now I'm going to have 2 to the power of 2 times 2, which is 4, divided by x to the power of 2 times 3, which is 6. Now, technically, when we have a whole number, we should simplify. So now that we've got the steps down, let's go back and simplify some of our solutions here. This solution right here, 2 to the 7th, is 128. This one is already simplified. 2 to the 12th is going to be huge. We get 4,096. Here, 2 cubed is going to be 8. And over here, 2 to the 4th is going to be 16. And these are my fully simplified solutions. All right, then let's go with a word problem. Part A of a multiple choice test contains 25 questions. Part B contains 36 questions. Each question has 3 possible choices. How many different ways can a student answer if they answer all the questions? Well, if each of my 25 questions, I have 3 answers, and there's 25 of them. And for the next part, part B, I have 3 answers, and there's 36 of them. To find how many possible solutions, I need to do 3 to the power of 25 plus 36. Notice I'm multiplying, and my base is the same, so I add my exponents. And now notice also that I did not multiply my bases. My base stayed the same, add your exponents. So I get 3 to the power of 61. And let's see what gigantic number that is. That is approximately 1.27 times 10 to the power of 29. Now notice that you end up with scientific notation when you do that on your calculator. So scientific notation is just exponents as well. I don't want to exchange one exponent for another exponent. So here's an easy way to double check yourself. If simplifying this gives you scientific notation, then don't simplify. Leave it in this form. All right, how about if I want to simplify right here? What operation is it? Yeah, I'm raising to a power, so what am I going to do to my exponents? Multiply, and I'm done. All right, how about right here? I'm raising a quotient to a power, so I'll get m to the 7th divided by n to the 7th times n to the 5th divided by m to the 5th. Now, hopefully you'll agree with me that I can write each of these, and I'm running out of space, so I'll move this up. Look right here. Hopefully you'll agree with me that I can write m to the 7th times n to the 5th in my numerator, and n to the 7th times m to the 5th in my denominator. Now here I can combine my m's. M divided by m would be m to the 7 minus 5. And, I'm running out of space, hang on. Equals m to the 7 minus 5. And I get n to the power of 5 minus 7. Do you agree? Now my final solution is m squared times n to the negative 2. Now we're going to talk more about negative exponents in a future section. But for now, I'd like you to write down these 3 questions and simplify. We get, I'm dividing, I get 3 squared. Does everyone agree 7 minus 2 is 3? I can simplify it, my answer is 9. Right now I get 3 to the negative 2, and for now I can't simplify. We're going to do more of that in a minute. My 0 theorem tells me that anything to the power of 0 is 1. All right, for tomorrow, and you're going to have 2 of these video questions tonight. For tomorrow, please answer these 4 questions, and now we'll move on to section 7.3. Now we'll move on. Now we're going to talk about those negative exponents. 3 to the negative 2 is a fraction. Whenever I have a negative exponent, I can simplify it by putting it in the denominator. And we'll talk more about why tomorrow in class. But for now, I'd like you to get the rule down. Whenever you have a negative exponent, it must cross the fraction line. And then, once your exponent is positive, you can simplify that. 3 squared is 9. Now we're done. Now, here, if I want to write each of these equations without fractions, W is going to have to cross the fraction line, which means its exponent will change. It was a power of 1, so when I bring it up to the numerator, it will be the power of negative 1. For n equals k divided by d cubed, d is going to come up to the numerator, so the sign on its exponent must change. Whenever a variable crosses the fraction line, its sign on its exponent must change. All right, so if we're going to write these as a single power, notice that I could either subtract and get x to the negative 3rd, and then simplify and put my negative exponent in the denominator where it becomes positive, or I could have brought x to the negative 8 up and multiplied. Notice that that would have also been an option. And from there I would get the same solution. Next one over here. If I want to write as a single power, I'm going to keep 3 in the denominator. And this time I'm going to go ahead and pull y to the 7th up. And now when I add, I get y to the negative 5th. And I can make that exponent positive by putting it in the denominator. Now, what should be in my numerator? If I've divided by something, anything divided by itself will always be what? Hopefully you'll agree with me, it's 1. So when you move something, this spot doesn't become empty, it always becomes a 1. All right. We're going to practice simplifying this first one right here. Remember, your exponent only has power over what it's touching. So this positive expression will stay in the numerator, and it will become 3 to the power of 3, x to the power of 3. This one will go in the denominator, and this one will go in the denominator. In my numerator, I now have 27x cubed, and in my denominator, I have 2 squared x squared times 4x. Now I can simplify, and in my denominator, I get 2 squared, which is 4. 4 times 4 is 16, and I get x cubed. Now notice, x cubed divided by x cubed is just 1. Or if you divided, 3 minus 3 would give you an x power of 0. And then anything to the 0 is also 1. So those are going to cancel. And this is my final solution. And I've run into my space over here. Here my 5b cubed is going to stay in my numerator. Let's go ahead and cube both those terms. 4b to the 5th will now go in the denominator. And let's go ahead and raise both of those factors to the power of 5. And in your numerator, what is 5 to the 3rd? Hopefully you agree with me that it's 125. And in your denominator, what is 4 to the power of 5? Let's see, 4 to the power of 3 is 64 times 16 more gives me 1,024 in my denominator. So I know that neither of these will have any common factors because 5 and 4 don't have common factors. And so now I'm looking at simplifying b cubed divided by b to the 5th. Hopefully you would agree with me that it's a division problem, so we're going to subtract. What is 3 minus 5? Oh, that's right, that's b to the negative 2. Where should b to the negative 2 go? If I have a negative exponent, shouldn't it always go to the denominator? And you are correct. So my final simplification puts b to the 2 in my denominator, and I'm done. All right, let's talk about writing word problems and using negative exponents. If fluoride is added to drinking water, the amount that's added is 1 part per million. 1 part per million looks like this. Isn't that the same as 1 over 10 to the 6th? So if I'm writing this with negative exponents, couldn't I just write it as 10 to the negative 6? Yeah, absolutely I can. 2 parts of fluoride is considered hazardous. If I want to write that with exponents, I would simply write 2 times 10 to the negative 6. Could I combine these? No, because my bases are not the same. I cannot simplify, and I'm done. All right, for tomorrow, here's your next set of 4. Now you have 2 sets of video questions. Please bring them on the same sheet of paper, and I will see you tomorrow.